So there are two concepts in this video that we're going to go over today is trig ratios, what they are, how to find them, and then also solving for sides using these trig equations. So first we're going to talk about trig ratios. So number one rule of trig ratio is that this only works on right triangles, okay? So only on right triangle. This is why it's called right triangle trig. So I'm going to go ahead and tell you what the ratios are and then kind of explain it. So we have three trig ratios. The first one is sine. So sine of some angle, and angle, I'm just going to name it theta, is equal to the opposite side over the hypotenuse. I'll explain what the opposite and hypotenuse is in a second. Then we have cosine, which is abbreviated COS, of an angle, is equal to the adjacent side over the hypotenuse. And last we have our tangent. So tangent of an angle is equal to the opposite side over the adjacent side. So some people like to use the mnemonic SOHCAHTOA so you know what sides go with what trig function. So we have SO for sine over opposite over hypotenuse. Ca for cosine is adjacent over hypotenuse. And then TOA for tangent is opposite over adjacent. And then together we have SOHCAHTOA. Okay, so how do these trig functions relate to this triangle over here? So first off, we have to have a given angle. In all these problems, you're either going to be given an angle, you might be a measure, it might just be the letter of the angle. So first, you need to identify the given angle. So let's say I wanted to find sine of r. I want to find cosine of r and tangent of r. So my problem is finding the r of these three, the trig ratios of these three things with angle r. So since they're all r is going to be my given angle because r is in these problems. One thing, your given angle will never be your right angle, never. So it's either going to be one of the two smaller angles. So r is my given angle. Now the second thing you're going to do is you're going to label the sides based on your angle. So this is very important because if you label the sides based on a different angle, you will get completely different answers. So, my different angles. So first off, you all know that the biggest side, or the side across from the right angle, is always the hypotenuse. This side will never change, okay? Always going to be the hypotenuse. Now, I have my two other sides, either my opposite or adjacent side. So based on my given angle, if I was to cover up my entire given angle, I couldn't see it at all, then the side that I don't touch is going to be my opposite side. Okay, so since I don't touch ST by covering up that angle, ST is going to be my opposite side. And the other side that borders our given angle is going to be my adjacent side, the only side I have left. Okay, so we've labeled our sides of the triangle, and now we're just going to plug in our values. So I have sine of r. So since sine is opposite over adjacent, my opposite side is r. My hypotenuse is S. My cosine of my angle R, cosine is adjacent T over hypotenuse S. And then tangent of R is my opposite side R over my adjacent side T. So these are my trig ratios. We're going to do an example of these with actual numbers. So for this example, we want to find these 6 trig functions. I'm going to start off with these first 3 because they all have the same reference angle x. So since x is my given angle, labeling my sides, that means 13 is my hypotenuse, 5 is my opposite side, and 12 is my adjacent side. So to find sine of x would be my opposite side 5 over my hypotenuse 13. To find my cosine would be my adjacent side 12 over my hypotenuse side 13. And then to find my tangent would be my opposite side 5 over my adjacent side 12. Okay, so that's for these 3. Now for these other 3, I actually have to relabel my sides because now they're different. So I'm going to redraw this triangle over here. So I know I have sides 12, 5, and 13, and x, y, and z. Those will all stay the same. But now my reference angle is different. My reference angle is z. So my hypotenuse, it will still stay the same. That does not change. But now if I look, my opposite side is now 12, and my adjacent side is now 5. And now I do these trig ratios based off this top triangle here. So sine of z is my opposite 12 over my hypotenuse 13. My cosine is my adjacent 5 over my hypotenuse 13. And then my tangent of z is my opposite side 12 over my adjacent side 5. And those are the 6 trig functions for this triangle. Okay, so for this problem, we're going to solve for the missing sides of zy and yw. So first off, I'm just going to put our trig ratios on the side here so we know what they are. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So since we're finding 2 sides in this problem, we actually have to do 2 separate problems, okay? So I'm going to split this page in half. In the first part, we're just going to focus on finding zy. So the first thing that we have to do is we have to label this triangle, okay? So label it using our given angle. So if I look at the problem here, the only angle that I'm actually given is 32, which is angle W. So this angle has to be our given angle. Also, what I think is going to help if we only label the sides you need. It'll help you figure out which trig function to use. Okay, so since we're finding zy, we're going to label that x, because that's the side that we need. So remember, if I cover up w and the side that I don't touch, that's going to be my opposite side. So this side, where x is going to be my opposite side. The side that's across from the right angle is my hypotenuse, but that's not a side that I need, so I'm just not going to label it right now. And then the other side that I don't have here is going to be my adjacent side. Okay, so I have my opposite side and my adjacent side. So the next thing I need to do is figure out, well, what trig function or what trig ratio do I use? So if I go over and look at my trig ratios, I want the trig ratio that has adjacent and opposite. There's only one. So sine has hypotenuse, which I don't have labeled on my triangle. Cosine has hypotenuse, which I don't have labeled on my triangle either. Tangent has both opposite and adjacent, so that's the one that I'm going to use. So I figured out that I'm going to use tangent, which is opposite over adjacent. Now, the last thing that you're going to do is you're going to plug in your angle and side lengths and solve. So let's plug in what I know. So tangent of my angle, so my angle is my given angle, so that is 32, equals my opposite side, which is x, over my adjacent side, which is 7. Now, like you would a normal equation, I'm going to solve this for x. So in order to get x by itself, I need to get rid of the 7. To get rid of the 7, I'm going to multiply both sides by 7. The 7 on the right side will cancel each other out, leaving me with just 7 times tangent of 32 equals x. So now this is where your calculator comes in, okay? We're going to plug it into the calculator. So I told you before that we can use the free calculator Desmos. So we're going to go to Desmos. So on your browser, just type in desmos.com. And you'll go down here at the bottom where it says scientific. We're going to click on the scientific calculator there. And you're going to type in. So I have 7, type in exactly as it is, 7. And then we have our trig functions. If you remember right here, these are our trig functions. So since we're using tangent, we're going to type in tangent. If you see when you type it in, the parentheses already appear. Like I said before, remember the tangent and the angle, they all have to go together. So this is 32. So tangent of 32, 7 times tangent of 32, your answer shows up on the side here. You don't even press enter. So as I said before in the previous video, make sure that you're in degrees. If you're not in degrees or if you're not using the Desmos calculator, make sure you are, because you will get a totally different answer if you're in radians. Okay, so our answer, we have 4.374. I'm going to put 3 decimal places because remember we have to round. So let's do that. We're going to get rid of this calculator. Okay, so we know our answer, that x equals 4.374. Now we need to round to the hundredths place. So to round to the hundredths place, we're going to look at the third number from the decimal. So since 4 is less than 5, we are going to, it's going to make this number in front, the second number stay the same, okay? So that means x equals 4.34, and that's the value of zy. So zy equals 4.34, and that's the value of that one side. Okay, on this other side, we're going to find the value of yw. So I have my triangle. I'm going to just redraw it over here. So we have a fresh triangle. So we have z, y, and w. We know this side is 7. And on this problem, we're trying to find yw. So I'm going to make that side A. So now first I'm going to label it. So since the A is opposite the right angle, that side A is the hypotenuse. And in 7, it doesn't change. It's still going to be the adjacent side here. Now, on this one, we're looking for a trig ratio that has adjacent and hypotenuse. So look up here. Adjacent and hypotenuse is this cosine right here. So cosine is adjacent over hypotenuse. So that's the value that I'm going to be using. So cosine of my W angle is adjacent over hypotenuse. Now I'm going to plug in my values. So I have cosine of W, which is 32 degrees, equals my adjacent side, which is 7, over my hypotenuse, which is A. So in this problem, we want to get a by itself. In order to do that, we're going to first multiply a on both sides. The a's on the right-hand side will cancel each other out, leaving me with a of cosine times 32 equals 7. So I still don't have a by itself. So the one thing I remember while I'm doing these problems is that this cosine of this angle, or if it's tangent or sine, whatever it is, it comes as a package deal. The angle and the trig ratio are always together. So if I move the cosine, I would have to move that 32 as well. So that's what I'm going to do. I'm going to divide off this whole side by cosine of 32. And then I'm going to divide the other side by cosine of 32. I know it does kind of look confusing, but what you're doing is you want to get rid of that cosine of 32 on both sides. On the left side. So once I do that, these will cancel out, leaving me with just a, which is what I wanted, a by itself. So a equals 7 divided by cosine of 32. Now that I have a by itself, this is the value, this is what I type into the calculator. So I'm going to go back to Desmos. Go to the scientific calculator and do 7 divided by cosine of 32. And that's my value. So I have 8.254, which is what I'm going to plug in. So which is going to be my x. My a. So a equals 8.254. Remember, we need to round. So this 4 is less than 5. So it means that the number in front stays the same. So a equals 8.25. That means that YYW is also 8.25. And this is how you find missing sides using trig ratios.